Today it is common to enliven virtual scenarios by means of crowd simulations, especially in the growing field of VR applications. This means that the entity's behavior is controlled algorithmically. Their trajectories are, for example, chosen in a way that collisions are avoided and that entities reach their goals. The aspect of authoring a complete population flow, however, is often neglected. So, how can we easily achieve this in a given scene in real time and in VR? Hello everyone, my name is Andrea Bönsch, and within the next minutes I will present a work-in-progress solution for this very question. Let's first agree on the difference between a crowd simulation and crowd authoring by means of this highly simplified figure. Crowd simulations focus on guiding entities, the small green icons here at the bottom, to their goal, the area at the very top. Thereby only walkable areas are considered, illustrated here in purple, between the grayish obstacles, which may represent, for example, buildings in a city. The exact path chosen by the entities is, however, of a subordinate importance. Of course, there are path characteristics like smoothness factors or always taking the shortest path, which influence the trajectory taken. But still, in typical scenes, several trajectory options remain, as illustrated in the animation here. In crowd authoring, we reduce these trajectory options and thus have more control over the population flow. We can, for example, block certain walkable areas or prioritize certain routes over others. Of course, we are not the first ones thinking about crowd authoring. Previous research proposed, for example, to adapt the navigation graph of a given environment by deleting certain connection or by giving additional information, which can then be used in order to choose a perfect route for the entities. For example, in this case, we defined indoor and outdoor areas, so an agent could be asked to only choose trajectories leading through the outdoor areas. Another idea is to work with user-adapted additional maps. A user can, as shown here, simply draw on top of a given scene, as known from tools such as Paint or GIMP. In this example here, the dark red areas mark buildings, thus unwalkable spaces which cannot be used by the entities. The light red areas mark streets, so they are walkable but should be avoided as they are mainly reserved for cars. Finally, the green areas are those to be prioritized by the entities as they mark pavements or other walkable free places. There were many more proposals in the literature, but I will skip them for the sake of time. However, one last solution should be mentioned here, and this is sketching. The two illustrations here show the work of Gonzalez and Maddock presented last year. Here, crowd authoring is understood as a pure add-on to crowd simulations. So we have a scene and a navigation mesh for the walkable areas, which is illustrated here in light blue, as well as a crowd simulation taking care of the entity's overall behavior, for example, in terms of collision avoidance. Then Gonzalez et al. Allows user to guide the flow by means of quite simple sketches. In the illustration on the left-hand side, the red areas and arrows build a small storyboard. The entities here start on the leftmost area, then they are divided into 3 groups and follow 3 different trajectories to the goal, the red area on the very right. In the illustration on the right-hand side, 2 long arrows can be seen in a kind of greenish color, functioning as flow lines, resulting in 2 entity flows with opposite directions. This solution is the basis for our work in progress. However, while this approach is limited to the 2D space of a normal desktop application, our solution is VR-based. Before presenting it, let me quickly explain our long-term goals. As stated in the beginning, enlivening virtual scenarios by means of crowd simulations is a growing field in VR applications. Thus, the idea is close at hand to also author the crowd in VR. However, the benefits and drawbacks of this methodological shift should be evaluated in terms of usability, time to author, and resulting plausibility of the flows. Second, if we have a VR-based crowd authoring, why only use it to set up meaningful population flows? We can also use it in different situations, for example, while exploring a scene. If we want to, for example, carefully inspect a certain location, we can simply reroute the agents so that they give us enough space while the scene itself remains lively. Thus, we are interested to evaluate whether real-time authoring can also be used as a useful tool or add-on during, for example, scene explorations. As a first step towards these two objectives, we implemented a small, straightforward sketch-based crowd authoring tool in Unreal. At the basis, we implemented a crowd simulation and visualized the resulting crowd as well as our scene in, then, of course, Unreal. Therefore, we used also the navigation mesh provided by the software. Based on user input, various sketches are added, and the respective information is used by the crowd simulation to adapt the entity's trajectories. A small set of sketch-based features, namely barriers, section, a flow control, as well as an option to process entities, is implemented, which I will demonstrate next. In this clip, a barrier is embedded and partially deleted again. A barrier is thereby an invious obstacle, blocking the entity's path. Thus, the entities need to adapt their path, as shown in this very short extract of the clip. On deleting single poles again, more trajectories options are again given, so entities might switch their path again, as the yellow agent does in here. And again, a small repetition. And all this works, of course, in real time. As shown in Figure A, a user sketches a line while a real-time preview of the line is shown as visual feedback. Once a sketch is finished, the preview is then replaced by actual scene elements, which you can see in Figure B. We decided to use barrier tapes here to intuitively blend in the boundaries of the walkable space. After the barrier is embedded, it can be altered by, for example, deleting the poles, as you saw in the video, or by relocating them. And on all these operations, the navigation mesh and thus the walkable space for our entities is automatically updated in the navigation system of Unreal, as indicated by the last figure D here. In the following short clip, I will demonstrate the sections with a small preview of the flow control. To embed sections, users sketch a convex area which is projected onto the scene's ground. During the sketching operation, you have again a real-time preview of the area as visual feedback, and once finished, the preview can be kept for sake of clarity as done here, but it can also be blended out. A section in general is defined as a waypoint on the entity's path and thus can be configured in different ways. Two of them you saw in the video here. It can be an entry allowing entities to spawn periodically during runtime, but it can also be an exit allowing entities who enter the section to vanish again. Finally, the section can be an interstation as shown here, so an interim goal of the entity's movement based on the section hierarchy. In contrast to the barriers, the sections are not embedded in the navigation mesh of Unreal. Instead, we sample random points in a section to get specific waypoints on the entity's path used by the underlying crowd simulation. By this, we avoid an excessive encroachment into the navigation system of Unreal, which saved a lot of work. And we think that it might have a positive side effect relating to future work. Right now, our sections cannot overlap. However, those overlapping regions might be of interest later on to create more versatile, however, also population movements. You already saw the crowd elements shortly in a previous clip, but let's have a look again at them in more detail. So we again draw two sections and connect them via an arrow which is drawn, and then they pop up. On the left-hand side, we see the panel which allows users to define, for example, the group size and spawn rate for entries, the section's density, so the amount of entities simultaneously allowed in a section, and the time entities are allowed to wander around in a section, which is important, especially for larger sections. So these are some additional parameters useful when creating or forming population flows. One might also think about further parameters in future work, for example, defining the walking speed in order to get more plausible entity behavior, By the walking speed, you could, for example, reduce the speed of entities in a park while increasing them when they cross a street. On the right-hand side, we see a panel to configure the transition probability. 100% means all entities coming from the entry use the defined transition. However, we might have a small storyboard or a small hierarchy as illustrated here in figure B. In the example shown here, only 20% of the entities spawning in the entry walk to the section called exit B, while the remaining 80% go to section A. The elements I demonstrated so far are all used in the, let's call it, third-person sketching perspective with respect to the entities. However, this perspective can be easily enhanced by an additional first-person perspective by possessing a random entity, as shown in the next short clip for the orange agent in the front. So we first have the third-person sketching perspective, and now we switch into the first person. This allows us to experience the scenario in life size, to get a first-hand impression of the configured flow. We can just stand there and look around, as you saw in the beginning, but we can also follow the flow and thus experience how it is to be an entity in this flow. We hope that this feature supports the authoring of realistic and plausible walking scenarios. We haven't had the time yet to do a careful evaluation of our VR-based sketching tool. Thus, we only conducted a first small feasibility check as a proof of concept, which an HTC Vive, and asked 7 students, 6 male and 1 female, to test it. First, they were asked to recreate different predefined guiding scenarios to get familiar with our interface. 2 examples of our specifications are shown here: a simple entry to exit flow in the back, as well as an extended version of some barriers in the front. We did not aim for one-to-one copies of our specification, but asked the subjects to recreate the logic of the flow closely. All subjects were able to use the tool, and some even intuitively used options in the familiarization phase which had not been introduced by then. After getting familiar, we asked them to solve a more complex guiding task shown here. So we had a small coffee shop with 2 narrow opposite doorways, and both are used by the entities to access and leave the coffee shop based on our initial configured flow shown on the right-hand side. We asked our subjects to reconfigure the environment, ensuring that, for example, one doorway is configured as an entry, the other one as an exit. All subjects managed to solve the task, and 2 exemplary solutions are shown in the figures here. On the left side, our configuration was extended by means of several barriers, while another subject decided to manipulate the initial configuration by only using sections and the flow control features. Afterwards, the subjects rated the ease of use of our approach via the system usability scale, resulting in an average score of 78.21. Although this shows that we already have a good usability, some improvement suggestions were named by our subjects. Examples are better positioning of the UIs for the flow control, or an option to delete complete barriers instead of just doing a pole-wise deletion, as you saw in the first clip. Luckily, all those features can be implemented quite quickly. In conclusion, we presented a preliminary VR-based sketching approach to directly and interactively author population flows in real time by means of barriers and configurable sections. A first proof of concept was promising, indicating that a VR-based approach is a suitable research object. It turned out that the elements and techniques used for 2D sketching are well applicable in VR. Furthermore, adapting the third-person sketching perspective in VR was supportive and also actively used, as our subjects quickly adapted their height in the scene to have different perspectives onto it. Lastly, the option to possess an entity and experience the flow firsthand was enjoyed, indicating that it might be a meaningful option to evaluate the flow guidance. In the next steps, the current design and UI will be improved based on the feedback of our subjects. Furthermore, more authoring elements will be added, for example, a storyboard to guide flows over a longer period of time. Afterwards, a detailed comparison between our approach and the 2D version of Gonzalez, which was kind of our template, shall provide insights into the difference of VR-based and 2D authoring. Lastly, we plan to examine the approach as add-on during scene explorations. With these last two steps, we can then finally focus on our research objectives introduced earlier. That's it from my side. Thank you very much for your attention.